Hi, welcome back. In this lecture, I want to give an introduction to the Dask framework that is widely used for parallel computing. So what is Dask? Well, Dask is a framework which is optimized for parallel execution using multiple CPU cores, but also on distributed systems such as supercomputer. You can scale from a single machine with a CPU with a multi-core to a distributed cluster and supercomputer. So that's why also is widely used in the area of HPC and supercomputing when using Python. It supports lazy execution, meaning that the computation only happens when requested. Similarly to the first version of a TensorFlow, where you create the graph and you explicitly need to ask to execute the graph with the task, Dask works in the same way. So it supports this execution. It creates a graph with the task, but explicitly we need to ensure to request the execution. So Dask also has the advantage of working with very large data sets. For instance, the data sets that cannot fit in the memory of a single node, but must be distributed across different nodes with different memories. So Dask allows us to handle this quite transparently. A main point, a very strong point of Dask is that it integrates quite easily with existing Python modules such as NumPy. So it can easily extend NumPy for distributed settings, pandas and scikit-learn. In this lecture, I just want to give an overview of the different way of enabling parallel computation using a different approach that goes under the name of a Dask collection. So I will start first describing Dask arrays, which are an extension of NumPy to parallel computers. Dask data frames that are an extension of pandas data frames, bags, which can be taught as a parallel list, Dask delay that enable general task parallelism, and last not least, Dask futures that are quite convenient when doing real-time parallel execution and workflows. So let's start first with Dask arrays. So what are the Dask arrays? Well, you can think as just an extension of NumPy arrays to distributed computing. So Dask arrays extend NumPy arrays to support large-scale computation. And how they do that? Well, they break the big array into smaller chunks and associate the chunks to a different process. So let's see here an example. So we import the Dask array as the A, and then we generate random numbers in a matrix, and then we say how we want to divide for different processes, and the keywords here is chunks. So we create a matrix 10,000 by 10,000 here with random entries, and we use chunks 1,000 by 1,000. So we will have different chunks. Then we can say which operation to perform, in this case element-wise computation, and this is lazy computation. So until here nothing had happened. So in order to actually have the computation, then we need explicitly to call compute method. Differently from NumPy, Dask does not compute results immediately, but instead it builds a task graph. Until here, it just builds a task graph, which is only executed when we call the compute method. So these are Dask arrays. Another useful extension, especially if you are using pandas for your work or for your studies to analyze data. Dask data frames are just an extension of pandas data frames that works by partitioning large data sets across different cores or machine. Dask data frame look a lot like a pandas. You can see here, read, CDVA, group by, but the execution is lazy, as I said in the previous slides. So you need to make sure to call the .compute in order to execute. In addition to Dask arrays and the Dask data frame, also Dask bags are quite useful These are equivalent to parallel lists. Dask bags are used especially for analyzing unstructured data like log files, JSON object, or text data. Dask bags are really great for map reduce style workloads where data is not naturally structured. Probably the lowest level abstraction that Dask has is the Dask delay that enables the general task parallelism. Dask delayed allows manual parallelization of any Python function and is quite useful when parallelizing custom workloads that do not fit into arrays or data frames. Last but not least, Dask features are great for real-time parallel execution and also for workflows. So they provide an interface very similar to the Python concurrent features and allow immediate execution across a distributed cluster. So it's not lazy anymore, but the execution is immediate. As I said, Dask features are great for real-time application. I want to close this lecture summarizing all the different features of the Dask collection approaches. I'm not going into detail. You have the slides in Canvas. In the next few lectures, I will focus on Dask delay, Dask arrays, and the Dask future. This is the last slides of the lecture. Talk to you soon.